let us today talk about the most difficult thing to prove in mathematics. So let us start with by explaining what is a Collatz conjecture. Now, if you take any number, if it is an even number, then you divide by 2. And if it is an odd number, you multiply by 3 and add 1. And you keep on doing this continuously forever. And the thing is, the Collatz conjecture says that eventually we'll reach to 1. For example, let's start with the number 10. It's an even number, we divide it by 2, we come 5. 5 is an odd number, multiplied by 3 plus 1, 16. 16 is an even number, multiplied by 2, 8. 8 is an even number, 4. 4 is an even number, 2. 2 is an even number, 1. So that's how number 10 comes to 1 eventually when you apply the Collatz conjecture rules to it. And it is true for 10. Now, what about 11? What about 12? You can keep doing it manually, but there are softwares out there, and we have till now calculate for millions of numbers that is true. So, but the real question is that's where the mathematics get really tricky when there are numbers involved in some kind of thing called conjecture where we have to prove something or not prove something. The thing is, there are infinite numbers. So, if you want to disprove something, okay, all you have to do is come up with an example which this rule doesn't satisfy. For example, there is a number n which is an odd number, and if you do the Collatz conjecture principle, it does not end on 1, but it ends on some another loop, like maybe 5, 8, 9, something like that. But it never reaches 1. Till now, we have not found such a counter example. All we have found is all the numbers which we try to prove, it follows it. So, is the conjecture true? No. In mathematics, we cannot say for a certain is a conjecture true or not. If you want to prove it false, you can try to find a counter example, which we haven't. But just because a million numbers, maybe a billion numbers, maybe a trillion numbers follows Collatz conjecture, doesn't mean it's true. Because all it takes is just one counter example to make it a false. So maybe it might happen theoretically that the 100 billionth number does not follow the Collatz conjecture. The rest all numbers follows it. We don't know for sure. So when there are numbers involved, since there are infinite numbers and it is humanly impossible to check all the numbers, because no matter how much numbers you verify, there is always be one number left to verify. If you verify the billions of numbers, I can always say, and the next number after that. What about that? Have you solved that? So we cannot solve such conjecture with brute force or mechanism. We can try to find a counter example with brute force, but till now we have failed. So all we need to do is try to find a general theme area with variables, and that is a quite difficult task in mathematics. So remember, when there are infinite numbers, there are infinite numbers, but when a formula or a conjecture deals with numbers and all you can find is numbers which follows the rule, it becomes very tricky. Collatz conjecture has become very famous for many years. Mathematicians have tried, banged their head, and they have not found a counter example because all the numbers they tried follows Collatz conjecture. But this, since it follows the Collatz conjecture, we cannot say it is true because there might be some number which does not follow. That's the case. That's the most difficult challenge problem solving in mathematics.